During the first 13 weeks of the television season, the Saturday night 8 p.m. to 9 p.m. audience proportions were recorded as ABC 29%, CBS 28%, NBC 25%, and Independence 18%. A sample of 300 homes 2 weeks after a Saturday night schedule revision yielded the following viewing audience data: ABC 95 homes, CBS 70 homes, NBC 89 homes, and Independence 46 homes. Test with alpha equal 0.05 to determine whether the viewing audience proportions changed. So our null hypothesis here will be that the population proportion for ABC is 0.29, for CBS is 0.28, for NBC is 0.25, and for Independence is 0.18. And the alternative hypothesis is that the population proportions are not as specified in the null. The observed frequencies are as follows, and the expected frequencies we can calculate using the proportions in the null hypothesis and applying those to the total sample size of 300. And if we do that, we get expected frequencies as follows. Then the chi-squared statistic: take the difference between the observed and expected frequency, square it, divide it by the expected frequency, and then sum over the 4 entries. So we obtain 6.9 for the chi-squared statistic. The degrees of freedom in this case, there are 4 categories, and so the degrees of freedom is 4 minus 1, or 3. If we look up the chi-squared distribution table and look along the row for 3 degrees of freedom, we find that there are a critical value of 6.251 and 7.815. They lie either side of our test statistic 6.9, and they have tail areas of 0.1 and 0.05, and so therefore our p-value, which is the tail area to the right of 6.9, must be in between 0.05 and 0.1. So it's larger than 0.05, our significance level. So in this case we fail to reject the null in favor of the alternative. So this means there's insufficient evidence that the audience viewing proportions changed after the schedule change.